In this video, we're going to learn how to solve a trigonometric equation. Before we go to details, I would like to show you guys what type of equation we're going to deal with. We have cosine of 60 degree equal to 1/2. If instead of 60 degree, if I put x over here, then we are dealing with an equation. So I could say solve for x. They would say, oh, x is going to be 60 degree. So 60 degree would be one of the solution. Let's have another example. Sine of x equal to 1/2. Solve for x. I'm going to say, oh, x, one of the solution is pi over 6 or 30 degrees. So not bad, correct? But sometimes the equation will be a little complex, like 4 sine square of x minus 3 equal to 0. So, you can see there are different type of questions. This is more complicated than previous example. Or we can have an equation like this. Sine square of x minus 3 sine of x minus 2 equal to 0. So in the next few videos, I will explain and we're going to learn different technique to solve trigonometric equation. Basically, we're going to use the same fundamental of algebra, like collecting like terms, factoring, square root. So we're going to use those tools to solve trigonometric equation. And you will see the goal is to make the equation like this. If I ask you guys to solve this one, so you will see how do we solve it, but the point is we have to break this one down, for example, by factoring. We should make it to something like this. We have to isolate the trigonometric function one side. Now in next few videos, I will make 3 type of videos. First one going to be, we're going to deal with the simple equation, like this. We're going to solve it. Then we make it to another level. You have to do a little more algebra. And the last video about solving trigonometric equation will be more complex. Cool. All right, let's start with solving the first trigonometric equation. So they ask us solve for x. And the equation is 2 sine of x equal to 1/2. No, 2 sine of x equal to 1. So in order to solve for the x here, we need to have this sine of x one side of equal side without any numbers. That means we need to get rid of these 2. So I can divide both sides by 2. I will get sine of x equal to 1/2. Now we need to look for what angle sine of that is 1/2. If we look at our unit circle, we see that we have 1/2 here. We have 1/2 at 30 degrees. We also have 1/2 at 150 degrees, or 5 pi over 6. So we have 2 solutions. If we go back to our equation, then x will be pi over 6 and x will be 5 pi over 6. So we have two solutions for sine of x equal to 1/2. Usually for a question like this, they will ask us, for example, solve for x when x is between 2 pi and 0. That means we're only looking for the x in one revolution. If this is our unit circle, we are looking for value 1/2 for the y value around just one revolution. If we don't have this, if they don't tell us the domain of x, then we need to do extra work. The extra work will be, you need to add plus 2 pi k, plus 2 pi k. Why do we need to do this? Because at 30 degree, we know sine of that is 1/2. Also at 390, we also sine of that is 1/2. Also, if we do 2 revolution at then end up being here, again we're gonna get 1/2. So we will have like an infinite solution that sine of that equal to 1/2. So in order to list all of them, we add 2 pi k. So we know what 2 pi is, I mean 1 revolution. The k is a constant number. Like when k equal to 0, we have x equal to pi over 6 plus 2 pi times 0, which is pi over 6. When k equal to 1, we have x equal to pi over 6 plus 2 pi times 1, which gives us 13 pi over 6. And k equal to 2, same thing. So we don't need to list them, we just give them a package like this. And this is a final solution. So we add 2 pi k if we don't have any domain. Let's have another example. Solve for x. X is between 2 pi and 0. So this is great. That means we don't need to deal with 2 pi k. The equation is sine of x plus radical 2 equal to negative sine of x. So our job is to have sine of x one side, and here it looks like we can collect them by adding sine of x to both sides. We're going to have sine of x plus sine of x. This side will go, and we have 2 sine of x plus radical 2 equal to 0. So now we have a new equation. We are looking for x. We are looking for this x, but the x is inside of sine of x, sine. So we have to have this package one side of equal sign and everything else the other side. So we get rid of this radical 2 by subtracting radical 2 from both sides. Then we have 2 sine of x equal to negative root 2. We divide by 2. Then we have sine of x equal to negative root 2 over 2. At this point, don't think you're done. No, we are looking for this x. We are not looking for sine of x. Now is a time to look at the unit circle. So let's go to the unit circle. We are looking for a value for x, which sine of that is negative root 2 over 2 and negative root 2 over 2. So we can see at 5 pi over 4 and 7 pi over 4, the value of sine of that is negative root 2 over 2. So let's go back. So we find the solution. Then x will be 5 pi over 4 and x will be 7 pi over 4. And we are done. So the unit circle that you have is very handy. Let's make one last question. Sine of, we don't need to have sine, we can have cosine. Cosine of x equal to 5 cosine of x equal to 1. And they ask us solve for x. It says solve for x. And x is between 0 and pi half. That means in the first quadrant. So in order to solve for this x, we should keep this one side of equal sign. So I divide by 5. I get cosine of x equal to 1 over 5. Now we need to look for what angle that cosine of that is 1/5. If you look at the unit circle, we can see that there is no value for cosine to be 1/5. So for what should we do here? Usually for a question like this, at the beginning they ask us to round it to 2 or 3 decimal places. That means they're not going to ask us solve the exact value. So at this point, this x will be cosine inverse of 1 over 5. So we have to use our calculator. Instead of your calculator, you will type cosine inverse of 1 over 5. Then whatever is that, you will round it to 2 or 3 decimal value. In next video, I will solve little more complicated equation.